Here are the homework answers. On number 1, 1/3 and negative 2.333. You could have 0.333 for the first x value. Notice that you find the derivative, you show each step in solving for 0, or setting equal to 0, and then you're plugging the x value into the original function, finding the point, and then showing the test to see if it's a max, min, or point of inflection. There is the graph for number 1. Notice that it's upside down. Problem number 2. Set the derivative equal to 0. Your x values are x and 5/6. So you plug those into the original function to come up with points of 0, 0, and 5/6 is the same as 0.833, and a y value that goes along with that of negative 1.157. One is a max, the other one is a min. Down here is how we figured out the max and the min. You must show that work as well. Here is the graph for number 2. Take note of 0, 0 as a max, and then 0.833 and negative 1.157 as a min. On number 3, the x value is negative 1/3. Plugging that back into the original, we get negative 5.333. Actually, that's wrong. It should be negative 6.667, as I have highlighted here on the actual point. So I can just go ahead and take that out here, and that should be this. And there's the test for max or min. It's clearly a positive, so this would be a minimum. Here is the graph. It's a bowl shape, so it's a negative 0.333 and a negative 6.667. This takes it out to 4 places. I only want you to do it to 3. There's the answer to number 4. Notice the x values are 0, negative 1, and 1. Showing all the work for the factorization. Plug each value back into the original function to come back with points of 0, 0, negative 1, negative 1, and 1, negative 1. The second derivative test, plug each x value into that and come back with a max, min, and a min, respectively. There is the graph. It is a W shape. The 0, 0 is clearly a max, and your other 2 points are minimums. For number 5, no real solutions when you try to use the quadratic formula on this. So go back and look at the graph. If you look at the graph, clearly 1, 0 is going to be a point of inflection. And there is over 1 up 0. Number 6. X value is negative 3/4. Plug that back in as either negative 3/4 or a negative 0.75, whichever, and come back with 5.125. Here is your point. Second derivative test is negative, so that makes it a max. Here is the graph for number 6. Again, there's the maximum point, negative 0.75 and 5.125. Number 7. You'll have a 0 and a negative 3. So plugging each back in, you're going to come up with 0, 0 and negative 3 and 27. Second derivative test for each, clearly shown, makes this a point of inflection because it came back to be 0, and this one a maximum because you had a negative answer. There is the graph. Negative 327 at the top, and then down there at the bottom, if I get rid of this, you can see that 0, 0 is the point of inflection. Alright, number 8. Negative 2/3. Plug it back in and get a point of negative 0.667 and negative 6.333. First derivative test is positive, so that makes that a minimum. And here is the verification for that. And answer number 9, 0 and 2 for your x values. Plug those back in to get 0, 0 and 2, negative 4. Your first derivative or second derivative test, and then plug in 0 and 2 respectively to get a negative 6, which makes this a max, and a positive 6, which makes this a min. And there is the graph to verify that. 0, 0 max, 2, negative 4 min. And number 10, an easy one. You have a 1 for an x value. Plug it back in to get a 4. Second derivative test is negative, so that makes it a maximum. And there is your graph to verify that. Today's objective is still the same. We need some more practice. This is to find and label all critical points of a function. Example number 1. f of x equals 3x cubed minus 4x squared plus 6x minus 3. Step 1 is to find the derivative. Oh, that is way too thick. There we go. And the first derivative is 9x to the second minus 8x plus 6. Now from that point, you must set it equal to 0. And then use the program on your calculator for the quadratic formula that we wrote a long time ago. Yeah, you come back with a non-real answer. Here is the graph. Whoops. Now what do we have in there? We have a maximum, and then there is a minimum. This is the right equation. 3x to the third minus 4x squared minus 6x minus 3. Ah, that changes everything. So now we go to plus 6x. And then what do you finish off with? Minus 3. Okay, I thought, well, how did we end up with non-real solutions, but we have a max and a min in there? Alright, so we'll zoom out and take a look at this. So clearly, right in here, you're going to have a point of inflection. Now if you think back to your equation, maybe I can write on this here, look at your y-intercept. It's negative 3, and that's where it's going to cross, and that is going to be your point of inflection. Example number 2. Find the first derivative and come up with negative 3x squared minus 8x and then plus 3. You're going to set that equal to 0. After using the quadratic formula, we come back with x values of a negative 3 and also of 0.333. Now you must plug those back into the original function. So it is f of negative 3. So that's a negative sign out front, and then put negative 3 in parentheses and cube it. If you don't, you're likely to end up with the wrong sign. Then minus 4 times a negative 3 squared plus 3 times negative 3 minus 1. So that ends up being a negative 27 from the work in the parentheses. But then you have another negative sign, so it's a positive 27. Here it is a 9 times a negative 4. We'll have minus 36. This will be a minus 9. And was that a plus or that's a minus 1? Yes. Okay. So this will be a negative 9. And then minus 9 minus 1, which is a negative 19. For your first point, you should have negative 3 and negative 19. Now go back and plug in 0.333 into the original function, and I'm not going to write all of that out. You know you're plugging it in for x there. come back with a negative 0.481. So you should have 0.333 and negative 0.481. Those are your critical points. Now we have to figure out if they are max, min, or point of inflection. So we'll go through and find the second derivative. Now the second derivative on this one should be negative 6x minus 8. And I have to write that down first before I go to the next screen, which I just have to slide over. Whoops. So the second derivative ends up being a negative 6x minus 8. Now what do we plug in first? Negative 3. So if we do that, then you end up with 18 minus 8. That's going to be 10. That's a positive answer, which means that's going to be a minimum. And then over here, what do we plug in next? 0.333. So it's a negative 6 times 0.333 and then minus 8. We'll come back to give you a negative answer, which means what? It will be a maximum point. So going back over, this one is a minimum and this one is a maximum.